at is graph a cube root function. We're going to graph y equals 1/3 cube root of x, and then we're going to state the domain and range. Just like we did previously, I've already put my xy table here, and I've chosen to use a -2, -1, 0, 1, 2, and 8. So I'm going to go ahead and start with my -2. 1/3 times the cube root of -2 equals. Alright, so we know that a -1 times a -1 is a +1, times a -1 gives me 1. Alright, so we need it higher than a -1. But we also found a while ago that for square root, I think it was 1.4 was about what we needed, but now we're looking at cube root. So I'm going to try 1.3. 1.3, -1.3 times a -1.3. So we have 3 times 3 is 9, and then 3 times 1 is 3. We always put our 0. 1 times 3 is 3, and 1 times 1 is 1. So I have 169, but remember we have 2 decimals, so we have to move over 2 decimals. But now we have to multiply again times a -1.3. So 3 times 9 is 27, carry the 2. 3 times 6 is 18 plus 2 is 20, carry the 2. 3 times 1 is 3, times 2 is, plus 2 is 5. And then again we start with a 0. 1 times 9 is 9. 1 times 6 is 6, and 1 times 1 is 1. So I have 7, 9, 5 plus 6 is 11, carry the 1 and 2. And I have 1, 2, 3. So I have to start here, 1, 2, 3 decimals. So as you can see, a -1.3, and this is negative now, cubed is actually a little over 2 is a little bit over 2. And so I'm going to go ahead and list this as 1/3 times, let's do a -1.25. That way it will hopefully get us closer to just -2. Alright, so I'm going to go ahead and erase this so we can finish out. And we have 1/3 times the -0.25. I'm going to say 1.25. 1/3 is 0.33. And again, this is a negative. We multiply. 3 times 5 is 15. We carry the 1. 3 times 2 is 6 plus 1 is 7. And then 3 times 1 is 3. Again, we start with our 0. We have 3 times 5 is 15. We carry the 1. 3 times 2 is 6 plus 1 is 7. And then 3 times 1 is 3. So now we add. 5 plus 0 is 5. 7 plus 5 is 12. We carry the 1. 7 plus 3 is 10. Plus 1 is 11. Carry the 1. And that gives me 3 plus 1 is 4. And we have 1, 2, 3, 4 decimals. 1, 2, 3, 4. So my y is going to be approximately, and again, this is my negative, a -0.412. And so far, that's what we've come up with. Now, I'm going to erase, and we're going to go again with 1/3 the cube root of a -1. So this one, it needs to be a little bit under. So I'm going to say a negative, let's do -8 times a -8. So this gives me a -64.64. And then if I want to times it by positive 64, negative times negative, by 0.8 again. This gives me 32, 4 times 8. We're going to carry the 2. 6 times 8 is 48 plus 3. Gives me 51. And again, we're going to move 3 decimals. Alright, so you can see that 0.8 cubed is only 0.51. So what we need to do is we need to go higher. And we're going to say a negative 0.9 and a negative 0.9. This is going to give us 0.81, and then we can multiply by a negative 0.9 again. So that's 9. That gives us 72. And we're going to move 3 decimals. And so therefore now I have a negative 0.729. But that's still not get us to a negative 1. And so what if I do, let's try 9 at 9. Negative 0.99. Alright, that gives me 81. I'm going to carry. That gives me 81 plus 8 gives me 89. Bring down to 0. That gives me 81. Again, we carry the 8. That's 81 and 89. So now we have 1 plus 0 is 1. 9 plus 1 is 10. Carry the 1. 9 plus 1 is 10 plus 8 is 18. Carry the 1. And that gives us 8 plus 1 is 9 with 4 decimals. Then multiply that times a negative 0.99. We have 9. Then 0 times 9 is 0. 9 times 8 is 72. We carry the 7. And we have 9 times 9 is 81 plus 7 is 88. And we bring down our 0. And we have the same exact numbers because it's by 9, 9. So I'm going to just go ahead and put that. I want to say 9, 0, 2, 8, 8. Now I want to add them up. 9, 9, 2, 10, carry the 1, 16, 17. And then 8 plus 1 is 9. And now we have our 4 right here. 1, 2, 3, 4, and we have 1, 2. So 1, 2, 3, 4, 5, 6. I'm thinking that that's probably as close to a negative 1 as we're going to get. And so I'm going to go ahead and put that down here. And I'm going to say 1/3 times a negative 0.99 equals. Now, for us to be able to do that, I'm going to erase again. And I'm going to say 0.33 times 0.99, a negative 99. We have 3 times 9 is 27. Carry the 2. 3 times 9 is 27 plus 2 is 29. I bring my 0 down. And we have the same exact numbers. So we have 7, 9, and 2. And then we're going to say 7, 16, 12, 3. And we have 1, 2, 3, 4. 1, 2, 3, 4. And we have a negative times a positive, so it has a negative. So my answer is going to be a negative 0.327. What we're going to do now is replace our x with 0. So I've got 1/3 the cube root of 0. So that means 0 times 0 is 0 times 0 is 0. So we can say 1/3 times 0, which is equal to 0. Now one thing you can look at is that we have 1 and 2. We've already found the negative 2 and the negative 1. So the only difference is the negative sign. So I'm going to go ahead and put that down. 0.412 and 0.327 because they're the exact same minus the negative symbol. So the last one we got to look at is 1/3 times the cube root of 8. Well, I know that 2 times 2 is 4 times 2 is 8, and so I can go ahead and say the cube root of 8 is 2. So 1/3 times 2, which gives me 2/3. And 2/3 is equal to 0.67. Now, from here, we're going to go graph. And so, I'm going to go ahead and say a negative 2 and a negative, basically half. So, I'm going to put my dot right there. I've got a negative 1. And again, it's a negative, and I'm going to say just barely above it. And then I've got 0, 0. And then I've got 1 and about a half. 2, about 3.2. 2.4. And then we go all the way over here to 8. 1, 2, 3, 4, 5, 6, 7, 8. And we're going to go up to 0.6. 0.67.
Miss Gibson.
So now I connect my dots. And there is my line. What I have to do is look at domain and range now. Again, remember that your domain is the X. And your range is Y. So this time you can see that there are arrows going both ways. So that means your domain, which is X, is all real numbers. And then your range, and that is going up and down, but you can see that it's going down. It's just going down very, very slowly, and so is that one. It's going up very slowly. So you can say that your Y is also all real numbers. One thing to keep in mind is when you're looking at a cube function or a cube root function, you should always have what I call an S-type curve. And when you see that kind of curve, your domain is always going to be all real, and your range is always going to be all real numbers also. The last portion that we're going to talk about today, or the last concept, is graphing of a radical function. When we're looking at radical functions, we're looking at y equals a square root of x minus h plus k, or y equals a cube root of x minus h plus k. Now, what we do in these instances is you're going to sketch the original function, which is y equals a square root of x, or y equals a cube root of x. From there, then we're going to translate. And when I say translate, what I mean is we're going to move h, which is inside the radical sign, left or right, depending on if it's a positive or a negative. And then we're going to move k, which is on the outside of the radical. We're going to move it up and down, up or down. And again, it's based on if it's a positive or negative. So they want us to graph y equals a negative cube root of x plus 2 plus 1. But like it says right here, we want to graph the original equation. So I'm going to do an xy table. And I'm going to do my xy table with -1, 0, and a positive 1. Now, keep in mind that they want us to sketch the original. Since this is cube root, I want to do the cube root of x. So I want to know what times what will equal a -1. Well, that is a -1. So -1 times a -1 gives us a positive 1, times a -1 gives us a -1. The cube root of 0 is going to be 0. And then the cube root of 1, again, 1 times 1 is 1 times 1 is 1. So we're going to come over here and we're going to graph the original. And so I'm going to go over and I'm going to go -1 to a -1. I've got 0, 0. And I've got 1, 1. So what I'm going to do is go ahead and graph. And why don't I do this? Because this was a negative, why don't I go ahead and say, okay, well, this right here is what we're looking at. Alright, that's the parent function, which is the cube root of x. Now, what we have to keep in mind is that this negative symbol lets us know that this is actually going to be flipped. So what I'm going to do is I'm going to go ahead and do that. And what that means is when I make this into a negative cube root of x, that means that my xy table is for a -1, 0, and 1 is now, this was a -1, but then we have to multiply it by 1. -1, so we have just 1, and then 0, 0, and then this one gives us a -1. So I'm going to go over here and I'm going to plot the points again. and I'm going to connect. So now we're looking at the red has the negative symbol. From the red, what we want to do is we want to move or translate, because this says plus 2, but the original says minus h. So to go from a minus to a positive, that means that we have a minus and negative. So because it's a minus and negative, that means that I actually have to move. I'm going to rewrite this as a negative 3 cube root of x minus a negative 2 plus 1. Now that you see it in this form, you can see that your h is actually a negative 2. Because of that, you have to move to the right, to the left 2. So I'm going to do that. I'm going to move to the left 2. And then this plus 1 lets me know I'm moving up 1. Alright, so my 0, 0 is now going to be over 2 up 1. And so my 0, 0 is now there. And now what I have to do is my negative 1, 1. This point, again, I'm moving over 2, and I'm moving up 1. And then the last one was the 1, negative 1. So we started here, and I'm moving over 2, and I'm moving up 1. So what you see now, which is the black, that is your translated function. And that's how you can graph without having to continuously try to figure out what is inside the radical and then solve it accordingly with multiple numbers, which is what we have been doing in the last couple of graphs.